Hello everyone, it's 1 p.m. Eastern and thus it's time to begin another of our monthly CoCoRaHS Weather Talk webinars. I'm your host Henry Regis along with our technical support team of Zach Schwalbe and Noah Newman. Nolan Duskin, my regular co-host, is unable to be with us today, but I'm sure he's listening in out there. Our Weather Talk webinars are sponsored by grants from NOAA's Office of Education and the National Science Foundation, and we're coming to you live from the Colorado Climate Center at Colorado State University in Fort Collins, Colorado. Today's webinar focuses on wind and wildfire. After our speaker's presentation today, we'll open up the webinar for questions from our audience. All of our webinars are recorded for future viewing on the web. We're excited to have with us today meteorologist Liz Page from the University Corporation of Atmospheric Research's COMET program right down the road here in Boulder, Colorado. Liz grew up in Southern California and is very familiar with the effects of wind on spreading wildfire, especially those Santa Ana winds. In fact, these effects of the wind on fire spread and later mudslides helped her shape her doctorate research. Welcome, Liz. It's great to have you as part of our webinar today.
Thank you, Henry. Can you hear me?
I can hear you. Let me go ahead and...
I think I'm unmuted. Okay, great. All right, well, thank you, and thanks, everyone.
Your screen up there. There you go.
Okay.
And, well, we've had quite our share of fires here in Colorado this summer, and, boy, many parts of the country are baking in 100-degree heat right now.
Yes, it's been a really rough year, especially out here in Colorado, and we're hoping that the season will calm down a little bit, but it's been a very active season as well as other parts of the country.
Well, Liz, we'll let you take it away from here, and we'll be back at the end of your presentation to take some questions.
Great, thank you. And thanks everyone for coming today to this webinar. Again, I'm Liz Page. I'm with the COMET program in Boulder, and I'm a project scientist there. I originally started my career with the Air Force and then moved on to the National Weather Service, where I was a member of the Riverside Ag and Fire Weather Forecast Office for a while, and there I trained to be an incident meteorologist, which I'll talk about a little bit more later in this talk if you haven't heard of that term before. I was never actually active on a fire as an incident meteorologist. I took the job with the COMET program to help them develop fire weather training, and I've been with them since, and we've had several projects that have dealt with fire weather and fire behavior, and most recently 2 of those projects dealt with converting classroom courses to online training. So if you're not familiar with the COMET program, we develop online training specifically for fire weather not fire weather forecasters, but weather forecasters in general, and we also have topics that are geared more towards the general public, and I will be showing you some of the training that we've developed related to that as part of this talk, and then I have some links at the end that can refer you to some of the courses if you're interested in more information regarding fire weather. All right, so just to give you a brief overview of my talk, I thought we'd start off with looking at some historic wildfires and then looking at fire seasons around the country and talk a little bit about the fire environment, how the environment in which a fire occurs affects the behavior of that fire. From then we'll move on to some extreme fire behavior and then talk a little bit about possible ignition sources for wildfires. We'll talk a little bit about the term the wildland-urban interface, which you've probably heard of and which has been a major factor in some of the wildfires, especially in Colorado this year, the Waldo Canyon fire, where many homes were lost because of their location on the wildland-urban interface. Also talk a little bit about fire weather forecasting, the contributions that the National Weather Service brings to firefighting as well as predictive services, which is made up of different representatives from the land management agencies. And then we'll talk a little bit about the post-fire flood risk. This has been an issue, obviously, in Southern California, the winter mudslides that you often see in areas that had previously burned, and also across the West in areas of complex terrain where you have a pretty quick response to rainfall events. In areas where fire has occurred, you see an even quicker response and also erosion and mudslides that occur related to that. And then finally, we'll take a look at the current wildfires. There aren't a lot of fires, but the West is still seeing some active wildfires. All right, so let's start off with some historic wildfires. And I have a link at the end of this presentation to a website that talks about some of the historic wildfires. The Weather Underground website has put together a nice description of wildfires, major wildfires across the country, and the weather factors that contributed to them. So, if we just start down here and go down the line, the largest, well, not the largest wildfire, but I guess the most deadly wildfire that has occurred in at least recorded history was the Great Peshtigo Fire in Wisconsin and Michigan. For those of you from the Midwest, you may have heard of this fire. This occurred in October of 1871. It was basically an out-of-control wildfire that was driven by strong southwesterly winds. They believe the ignition point, or the place where it began, was due to fires from logging camps. So fires that were being used in logging camps went out of control with these strong winds that developed. Then the Yellowstone fires, which occurred in August-September of 1988. Again, this was a very large fire in the Yellowstone National Park. For those of you that remember it, it burned about 1.2 million acres. There were 4 fatalities. These were actually not inside the park, but they were related to fighting the fire. And again, winds played a key role in spreading those fires as well. In October of 1991, the Oakland Hills fire, where 3,800 homes were lost, and 25 fatalities occurred. These were associated with the Diablo winds, similar to the Santa Ana winds that occur in Southern California. So again, you can see that wind is a factor in all of these. It's obviously not the primary factor, and we'll talk about a little bit more when we talk about the fire environment, that there's other issues that occur as well. But these winds were instrumental in maintaining these fires and causing them to be as severe as they were. In July of 1994, we had the South Canyon fire, which was on the western slope in western Colorado. It was a relatively small fire, and then it burned 2,000 acres, but the fatalities, 14 fatalities that occurred, were actually firefighters on the fire. Winds played a key role in these fatalities, in that the winds switched and moved up the slope. And we'll talk a little bit about how combining upslope winds with the natural tendency for fires to flow upslope causes a rapid increase in fire spread. And these firefighters were overcome by the fire as it spread rapidly upslope. In April and May of 2000 was the Cerro Grande fire, which was near Los Alamos, New Mexico. In this case, the fire burned 47,000 acres, and 235 structures were lost. There were no fatalities, fortunately. The significance of this fire is that it started out as a prescribed burn and turned into a wildfire. It also burned near the Los Alamos National Labs, and I'm going to talk about that fire in a little bit more detail. So the next fire on our list is the Cedar Fire of October 2003. This occurred in Southern California near San Diego, in the San Diego suburbs. 280,000 acres were burned, including over 2,800 buildings, and this was due to a Santa Ana wind event, which is very hot, dry, offshore flow that comes from the eastern part of California and affected the fire spread significantly in the case of this fire. And then finally, in March of 2006, I wanted to show that there were fires outside of the western U.S. We tend to focus on fire behavior in the western U.S., but fire actually affects the entire nation. These Texas wildfires, over 1 million acres were burned in March of 2006. There were 12 fatalities, and again, strong winds played an important factor in the spread of these fires. An important characteristic of these fires, there were 200 fires that were started in 24 hours, and they spread very quickly. So just the effects of the winds, some of the ignition points were due to the winds themselves and down power lines, and that had an effect on the spread of the ignition and the spread of those fires. Okay, so I wanted to concentrate on 3 of these particular fires and talk about what makes these fires historic. I think that one thing that comes out from all of these fires is the attention that the land management agencies and the agencies that support them, such as the National Weather Service and FEMA, put a lot of attention into learning lessons from these wildfire tragedies. So I wanted to focus on 3 of these fires and talk a little bit about how they changed the way things worked, basically, or the way things are approached with respect to wildfires. So the Yellowstone fires, again, this was a very large fire that occurred in Yellowstone National Park. It lasted for a couple of months. it brought attention to the way that the U.S. fire management brought attention to the fire management policies of the U.S. government. There had been a long period where fires were suppressed once they started, and in the early 70s that attitude was changed, and the idea was that some fires are needed to burn because fire is a natural part of the ecosystem, and that it's important that it be allowed to be part of the ecosystem so that we can then help control major fires from breaking out. But in this example, this was a major fire that broke out. There is a greater emphasis now on the role of natural fire in the ecosystem. So fires that occur naturally, say by lightning ignition, are often allowed to burn in Yellowstone unless they are threatening some area of the park. So in general, this really helped start to change the attitude about fire itself, and that fire was not necessarily a bad thing, and that they could be incorporated into the natural land management procedures. Next one I want to talk about was the Oakland Hills fire. This fire really demonstrated what happens when a wildfire reaches a suburb. So if you remember, the Oakland Hills fire had a substantial number of homes that were lost in the area. It highlighted a lot of things. It highlighted the fact that fuels are not necessarily just forests and grasslands. The fuels can take the form of homes, the wood roofs, and the landscaping, and that neighborhoods should be planned so that you can both control the effect of fire in the area, or try to control the effect of fire, or at least mitigate the effect of fire in the area, and just make some good decisions about the way that neighborhoods are formed, the type of building materials that are used, and the type of landscaping materials. So in the case of the Oakland Hills fire, there were many homes that had wood roofs. There were landscaped extensively with eucalyptus trees, which we'll talk about a little bit later, are very volatile trees. They burn hot. They have volatile chemicals in there that help, initiate the fire, ignite the fire to begin with. So this situation was, a lot of lessons were learned within the situation, including having evacuation plans, having accessible roads. The roads were very narrow in this neighborhood. There was another problem with, once homes were burning and the neighborhood didn't look the way it did, people were having a hard time navigating the way out of the neighborhood. And also the availability of water to support the firefighting activities was limited. So all of these things that happened with this fire have formed and have made changes in the way both neighborhoods are planned and also the way that firefighting activity occurs. Now the Sierra Grande fire, I wanted to talk about this a little bit because it was what was called a controlled burn that became a wildfire. And just want to talk a little bit about that terminology. The terminology that's used now is prescribed fire, which means that the fire is set on purpose to help with the land management activities, to help mitigate the occurrence of even more severe wildfires. Unfortunately, this one became a very severe wildfire, and it destroyed 280 homes, 40 buildings on the Los Alamos Nuclear Lab campus were burned. There was no nuclear material that was burned, but there was some concern about what a fire on the Los Alamos Nuclear Lab would mean in terms of public health hazards. So this fire had a major impact on prescribed fire operations in terms of planning for the prescribed fire, in terms of monitoring it, and just being more aware of the fact that these prescribed burns can then become wildfires, and what that means in terms of areas where there's populated regions as well. So again, all of these fires had had some very severe consequences, but the agencies involved have evaluated them extensively, and you can find out quite a bit of information on the web about these different fires, and actions were taken to help mitigate these issues occurring again. So I wanted to talk a little bit about fire weather climatology. We actually have a, oh sorry, I hardly ever get phone calls. Okay, we have a module called Fire Weather Climatology that was developed for the National Weather Service for the Advanced Fire Weather Forecasters course, And part of this, we have a description of fire seasons and show how they vary depending on the location. So I wanted to show you that. And again, this is part of this module on fire weather climatology. So what you're seeing on the screen, and hopefully you're seeing on the screen, Henry will let me know if it's not showing up, is the U.S. and Canada, basically North America minus Mexico and Central America. And what we have here is different regions of the United States broken up by the regional patterns that we see in fire season. So if we go to the Central Rockies and the High Plains, which is the areas where I'm located, you can see that the primary season is from June to September, and it's a little bit earlier in the Northern Rockies. There's a secondary fire season, which occurs before green up in April and after the killing frost, which is in November. And occasionally there's fires May through October. So you can see that fire can affect the region many times of the year. We've seen our fire season in June be very active, and July as well, and we'll see that the fire season will continue through the fall. All right, so some of the other areas, since we have people that are not from the West, I thought we'd talk a little bit about the Great Lakes area. Their primary season is April through May. Again, the season occurs before green up of the vegetation. So when the vegetation is dead, the temperatures are starting to warm up, things are starting to dry out a little bit, that's when you see the fire season come. Once the vegetation starts to come back and is greener, then it's more difficult for it to burn. You'll see occasional fires during the summer months and in March and November, but in general their main fire season is from April through May. So if you get cold fronts that move through the area, they can bring heavy winds, and you have some type of ignition that occurs, whether it's down power lines or whether there's some other source of ignition, that's when you can get substantial fires in this region. Now, New England as well has a fire season. You don't hear very much about fires in New England, but there is a fire season there, and again, it's very similar to what we saw with the Great Lakes area. It's primarily in April and May, with the secondary season in October and November. And again, this is sort of a pre-green up situation. Fires tend to be smaller in the New England area, but can still have an effect on damaging homes and buildings and populated regions. If we move to the Southeast, the Southeast has a fire season as well, and there's quite a bit of fire activity in Florida and Georgia, and we'll talk about the fire activity in Florida in a little bit, but I just wanted to show this out, that their primary fire season is February through May, when they have drier conditions, and the fuel moisture levels are usually highest into the summer and early autumn. So it's in the areas where we have lower fuel moisture, where we have drier conditions. The interesting thing about the Southeast is that fires can occur under conditions that you would not normally associate with fire conditions in the West. So from people from the West, it can be surprising to hear how how high the humidity can be and fires can still burn, or what the critical values of humidity are, which can be as around 30% and higher. So it's an interesting location if you've studied fire in the West and then look at the fire conditions in the Southeast. And we also have information about Canada. We have information about Alaska. Alaska fires can become very large. Alaska is a very large place to begin with. In general, fire is used as a natural part of the ecosystem in Alaska, and fires are allowed to burn unless they're threatening some type of commerce location or a populated region. All right, so I encourage you. I put a link in the presentation if you'd like to learn more about the fire seasons and the different regions in the U.S. You can take a look at that.
Liz, this is Henry. Will we be able to get a link on our website for this too? That people
Yes.
be able to access? Okay.
Yes. I owe you links for the website, and I will.
Okay, and for
I
folks
will
out
get those
there,
to you. Sorry.
for folks out there, we'll have those posted probably later in the week. So if you're looking, we will get them up. Okay, thanks.
But I have this included right now in the last slide, so I'll send those to you as well.
Super.
All right, we go. click the wrong link here. Let's try that again. Here we go. Okay, so that's just a little bit that I want to talk about the fire regions and the different seasons that occur. So the fire weather climatology module talks in more depth about the types of weather patterns that are associated with critical fire behavior. So if you're interested in that type of information, you can get that from that module as well. Okay, now I chose the Waldo Canyon fire, which occurred near Colorado Springs in the most recently. It was a very recent fire here in Colorado, and it has some characteristics of the things that I wanted to talk about during this webinar. So I've used the Waldo Canyon fire as examples as we go through these different topics. So the Waldo Canyon fire, it exhibited extreme fire behavior, which included spotting and crowning. We'll talk about what those terms mean. The winds were interesting in this fire, in the fact that they were strong enough that they were affecting the natural effects of topography on fire spread. So fire normally spreads uphill based on the it's the topographic influence on the fire behavior. The winds were strong enough that it was actually forced downhill. The fire created its own winds, which is another form of extreme fire behavior, and that is actually what caused it to move into the populated area of Colorado Springs. Also, the fuels were well cured and ready to burn. There had been hot and dry conditions, and there's as you probably heard, there's a drought over much of the country right now. It also showed the influence of the wildland urban interface, which means that there were neighborhoods that were built up against the wildland areas, and those were the areas that were affected by this fire. Also, there was an IMET on site. We're going to talk a little bit about incident meteorologists. We had an IMET on site, and she did a great job describing the weather conditions that affected this fire. And there's also this post-fire flood potential. The areas were burned severely enough that these regions are going to be more susceptible to flash flooding, and the Weather Service is taking action now that as rainfall falls over these regions, that there is a special alert put out to the people in the burn regions that there's even a greater potential for flash flooding due to rainfall events. All right, so I couldn't resist. I had to write, where's Waldo? So the Waldo Canyon fire, this occurred near Colorado Springs. Colorado Springs is sort of in the center of Colorado, and just for reference, the CoCoRaHS headquarters is in Fort Collins. There was a High Park fire at the same time burning, and this was actually had a short-lived notoriety as being the most damaging wildfire until the Waldo Canyon fire occurred. So I wanted to show you a little bit with this is an interactive map that was put together by the Denver Post, and it has information about the different fires. So the Waldo Canyon fire, which again was near Colorado Springs, this burned to 18,000, a little bit over 18,000 acres. So it wasn't a huge fire. It was a substantial fire, but there have certainly been larger fires in the past. But it did cause quite a bit of damage because it did burn into neighborhoods in Colorado Springs. The High Park fire, which was, let me click on the fire icon here, which was to the north near Fort Collins, this also was a very damaging wildfire. This grew to over 87,000 acres. And at the same time, just skipping along the Front Range here, just west of Boulder, there was the Flagstaff fire, which was a relatively small fire, thankfully. It was right near the edge of Boulder, so there were people that had pre-evacuation orders if that fire was going to come over the ridge. But it was in the foothills, basically just to the west of Boulder, and was behind a ridge. And luckily, it just peeked over the ridge for a little bit, but it was contained relatively quickly. Okay, so this is just to give you a reference of what was going on in Colorado. Obviously, there were other fires going on as well in the western part of the state and the southern part of the state. But I'm going to focus on the Waldo Canyon fire because of all the interesting aspects of it. All right, so let's talk a little bit about the fire environment. We have this fire environment triangle, which is to the right here, and it has three sides, which are fuels, weather, and topography. Each of these components has an effect on the way a fire behaves. So basically you have to have dry fuels, in order to have an ignited fire spread, the topography is going to influence both the speed and the direction of that spread, as will the weather. So that we have these three different sides of the fire environment triangle. Each has an effect on fire, but as you can imagine, weather is the most variable. Fuels will vary in terms of the fuels that are available to burn, in terms of whether they are alive or dead, whether there is sufficient fuel moisture or sufficient lack of fuel moisture for them to burn. Topography isn't going to change drastically unless, I guess, there's an earthquake or some other type of major geologic event, but weather will change very rapidly, and weather will have an effect on the conditions of the fuels. All right, so in the case of the Waldo Canyon fire, the fuels were well conditioned. It had been very hot and dry, and these conditions had dried out the vegetation. There hadn't been a lot of rainfall in the region. The topography was what we call complex, meaning it was in mountainous terrain. It was near the foothills, just to the west of Colorado Springs, and the weather was hot and dry. So there were thunderstorms that were developing, but they had very little rainfall in terms of being able to put out the fire, and there were very gusty winds associated with those thunderstorms. So all of those conditions made it a prime location for, if a fire were to ignite, for the fire to spread. So if we look at the different legs of our triangle and start off first with topography and talk specifically about how the slope of an area affects fire. We see that fire naturally moves upslope, and that's what I'm trying to show in this picture here. So you have a little bit of a slope here. You can see that the burned area is downslope and the fire is progressing upslope in these grassy regions below the trees. What happens is that the fire is sort of bent down towards these fuels that are ahead of it, and it preheats the fuels. Fuels have to heat to their ignition point in order for the fire to continue to spread. So we see that the fires spread uphill and that they spread more rapidly as the slope becomes steeper. So I got a little animation to show you associated with that. And we can see that on a flat, relatively flat area, meaning 0 to 20% slope, we have our fire that's just burning here. If we increase our slope to 20 to 40%, we see that the flame height, in other words, how high the flames are actually extending up into the air, increases by a factor of 2. The spread increases by a factor of 4. And as we continue to see an increase in the percentage of slope, we see that the flame height and the spread rate also increase. You can see that the increase in the spread rate is more substantial than what we see in the flame height. So a 60 to 80% slope will see an increase of 14 times in the spread of the fire. So that you can see that as you are moving up, or as your fire is encountering slopes that have a greater percentage of slope, that you will see a much faster rate of spread of that fire. So we also see that there's what we call diurnal changes, or these day and night changes in the flow. And during the day, we see a natural development of upslope winds as the ground heats. And we see that as the ground heats, the air rises and air moves up from the bottom of a valley up along a slope in order to replace the air that's rising off of the slope. And at night, the ground cools and downslope winds begin to form. So I also wanted to show that through an animation. And as you can see, this is our nighttime view. We have smoke that's settled into the valley. Right here on the left-hand slope, I guess you could call it, we have a fire that's just sort of smoldering, just not very much activity. Once the sun rises and those slopes start to heat, we see that this upslope flow starts to form, and then you have the combination of the fire moving naturally upslope and the winds moving upslope. Those act together to increase the spread of the fire. So as the day goes on, the valley continues to heat. We'll see that the wind flow will start to shift a little bit so that it's more up the valley itself, and that also will have an effect on the fire, the direction of the spread. So you'll see that it'll start to spread a little bit more up the valley. And then as the heating continues to occur, we'll see an up valley flow itself. So up the valley itself, the flow will start to increase and strengthen. Then as the sun starts to go down and the slopes are shadowed, we'll see that the activity of the fire starts to die down, that the upward progression of the fire decreases. We'll see these downslope winds start to form, and then a down valley component will form as well. And if you've ever been on the front range of the Rocky Mountains, or probably any mountain area, you get these valley breezes at night, which are nice cool breezes that help cool things down. So the fire itself, the suppression is somewhat, the fire spread is suppressed. We see that the fog the valley starts to fill up with smoke, and that it's a good time for firefighters to try and work on the fire in suppression tactics to when the fire spread itself is decreased. All right, so some general wind effects on fire spread. We see that basically a fire will spread in the direction the wind is traveling. So if we have a 1 mile per hour wind flow, and this is directed towards the east, it's a westerly wind, then we see that the fire will move in that direction. It has sort of this, rather than a circular motion, we start to see more of an oval shape to the fire spread. And as our fire speed, as the speed increases of the winds, then the fire takes even more of an elliptical shape. And again, it spreads in the direction of that wind. And then you can see with those very strong winds that it's moving even faster, and that the shape itself, that it's a more narrow shape to the burn scar. All right, so in winds and terrain, again, we've talked about upslope winds act with the slope and affect the fire so that it spreads faster. Again, the South Canyon fire is an example of that. That was the one that occurred near Glenwood Springs, Colorado, where 14 firefighters died as the wind speed shift so that the winds were directed upslope. They're relatively strong winds, and that it acted with, it was a very steep slope as well. It acted with the natural tendency of the fire to move upslope and caused the fire spread to increase dramatically. So downslope winds can cause a fire to slow down or even move downslope, and that's what we saw with the Waldo Canyon fire. I'll talk about that a little bit more on another slide. So one of the things I want to show you is that one effect, meaning the weather effect, can overcome the natural slope effect. So in the Waldo Canyon fire, the fire did spread downhill due to strong winds. This animation isn't specifically for the Waldo Canyon fire, but it's illustrating the idea that I'm trying to get across is that fire will spread relatively rapidly upslope. As it moves down over the ridge, it will also move downslope if the winds are substantial enough. As the fire continues to spread and creep downslope, we'll see that it will move in, and as it moves towards, it's going to move towards the slope over here. As it moves towards the slope, then the activity of the fire and also the fire spread rate will increase as well. All right, so in terms of the effects of weather, in addition to wind, relative humidity has an effect on the fire environment and on fire behavior, in that it affects the fuel moisture. So the amount of moisture in the fuel has an effect on how quickly and basically how quickly that fuel will ignite. Basically, all of the moisture has to be taken out of the fuel to begin with, so it's dried out by the fire, and then it's available for combustion. So changes in relative humidity can affect the fuel moisture, and that decreased relative humidity conditions can actually decrease the amount of moisture in the fuel. Moisture will move out of the fuel, just like our lips get chapped more in dry conditions as you can feel the moisture coming out of your body. So the time it takes for these moisture changes to affect the fuels is based on the size of the fuel itself. So if you think of being, say, in a forest where you have pine needles on the ground, those would be considered 1 hour time lag fuels. This time lag is what the time it takes for the fuel to react. So in an hour, these fuels will start to react to decreases in relative humidity. They react to increases as well, but in terms of enabling fire spread, a decrease is what we're looking at. So 10-hour fuels have diameters of about 1/4 inch to 1 inch. So these would be, say, branches that have fallen off of trees. If there's some type of litter on the ground due to, say, logging operations, these relatively small pieces of wood would then react on the order of about 10 hours. 100-hour fuels are between 1 inch and 3 inches, and again, this could be the same type of thing, either small shrubs or whether they are, something that's fallen out of the tree, some type of timber litter or some type of logging slash will react to that. And then the 1,000-hour time-lag fuels have diameters between 3 and 8 inches. So you can think of these as maybe trees that have fallen down, logs that are on the ground, these larger fuels. It takes them a longer time to react to changes in relative humidity. But in the case of the Waldo Canyon fire, we had sustained conditions of very hot and dry conditions in the area. So even the 1,000-hour time lag fuels were affected by these dry conditions. Okay, so the last thing here is fuel influences on fire behavior. We've talked about topography, we've talked about weather, and now we're talking about fuels. And fuels are basically anything that burns. So the types of characteristics of fuels that we look at in order to determine what the fire behavior might be is the loading, which is basically the amount of fuel, how dense the forest is, how dense downed fuels on the ground might be, the size and shape. We see that smaller fuels are more likely to ignite. Areas that have a larger surface area to volume ratio, in other words, they're very thin fuels or very long fuels, pine needles would fall into that type of example. The compactedness of the fuels, similar to when you're trying to start a fire, a campfire or a fire in your fireplace, you don't want the fuels all compacted on each other. You want to have some area in there for oxygen to get in and to promote the ignition of the fuels. So again, if fuels are not very compact or if there's enough air in between the fuels, then those will be more likely to burn. The horizontal continuity, if you have a nice horizontal area covered with fuel, then again that will help with the fire spread, as you can probably imagine. That if you have an area which has an abrupt loss of fuels, which is what they're trying to do when they're building fire lines, is scrape all the fuels off the ground so there's nothing to carry the spread of the fire. Vertical arrangement is also an important feature. Vertical arrangement basically is there some mechanism for, say in a forested region, for the fire to move up from the ground into the trees? And that's what I'm trying to show here is these trees are torching here, and this will affect whether the tops of the trees will ignite as well as the fire that's occurring on the surface. And we'll talk about why that's an extreme, that's considered extreme fire behavior when the fire moves into the tops of the trees. The moisture content of the fuel is important, and the chemical content. If there's some chemical within the fuel that will make it more likely to ignite, then that is going to be a situation that will spread the fire more rapidly. All right, so chemical content. Some fuels that you've probably heard of, the eucalyptus trees, are very volatile fuels. They will ignite and burn very hot. Chaparral is another example, which is common in Southern California. That's what we're seeing right here is an area of chaparral. And then palmetto trees in the southeast, if you're familiar with those, this is what we're seeing here in the bottom picture. These also are very volatile and will carry fire very well. They also make firefighting very difficult. You can see how dense this palmetto patch is. You can imagine trying to walk through and clear this region would be quite a task. Okay, I also want to talk a little bit about grass fires. Grass fires burn very thoroughly and very quickly, so fires in grass can spread very quickly. Luckily, these burned areas can act as a barrier for fire spread, so once the area is burned out, which is what we're seeing right here, we're seeing a firefighter who's doing a back burn, basically burning this region to make a barrier to increase the effect of this road right here in terms of limiting fire spread. And in Texas and Oklahoma, these aren't highly, well, many of the areas are not highly forested areas, and the Texas and Oklahoma fires spread very quickly. They were highly affected by winds. The strong wind speed, the strong winds associated with cold fronts that were going through that didn't have a lot of precipitation associated with them were responsible for these fires becoming so large. There's also peat fires that occur in bog areas. So those of you that are in the Midwest, I guess the greatest amount of these bogs are available in Minnesota. That's what I read on the web yesterday anyway. And this also affects the southeastern portion of the U.S. I believe this is actually a bog in West Virginia. So in times of drought, these areas of peat can be dry enough that they will actually ignite. And it's a interesting fire situation and a dangerous fire situation in that these fires can go underground inside the peat layer and last for a long period of time. And then every once in a while they can ignite the surface vegetation, just kind of flame up the surface vegetation and start a new fire. So peat fires are very difficult to put out, and they can cause problems for quite a while. And these are situations that occur all over the world. There's a large peat fire in Russia. There's been huge peat fires in Indonesia. It's a very dangerous situation when you're under drought conditions. All right, and then finally I want to talk a little bit about Florida fires. I think Florida has a huge number of fires. They have a huge prescribed burn. They do a large amount of prescribed burns. They treat over 2 million of acres each year. The problem with this is that the big hazard that it causes is that you can get smoke along the highways. And if you've driven in Florida along the highways, every once in a while you'll see signs that say don't drive into smoke, because it can be very dense smoke, and it can cause some serious large car accidents associated with the smoke on the highways. The conditions, as I mentioned before, are very different from the West. You can have relatively high relative humidity values, what we would consider high in the West, and the fire can still burn. And this is a picture right here of a land manager setting a fire. Again, this is a prescribed burn that's occurring in Florida. You can see the palmetto and the pines in the background of the picture. Okay, I want to talk a little bit about extreme fire behavior, and here I was worried that I wasn't going to have enough time or wasn't going to be able to fill up the time, and I'm doing quite well here. So I'm going to talk a little bit briefly about extreme fire behavior. This includes spotting, crown fires, fire whirls, and plume-dominated versus wind-driven fires. This is actually terminology that I think the land managers would like to change, but they're still in the process of doing that. But it's very descriptive of what we're trying to talk about here. So spot fires are basically burning embers that fly out of a main fire and start a new fire. This is an example of a spot fire here. So so this is a very dangerous situation. If you have strong winds, the burning embers within the main part of the fire can actually be picked up and carried quite a ways downwind. This was an issue in the Waldo Canyon fire. Crown fires are fires that spread through the tops of trees. So this is an example here of a crown fire. You can see the trees that are completely engulfed in flames. They will also the wind will carry this fire along the tops of the trees, and it can move very quickly, faster than what the associated ground fire would move. So again, this behavior was also seen in the Waldo Canyon fire. A fire creeped downslope, and then it hit an upslope region where the trees began to torch, and a crown fire took it very rapidly up the slope. I want to talk a little bit about the winds in the Waldo fire. This is from the incident meteorologist that was on the fire. Again, the fire was driven downslope by winds. These were generated from thunderstorms, which were actually over the Hayman burn scar, which is a little bit to the west of where the fire region was. The fire column was well developed, so you had this large, I don't know if you heard the term pyrocumulus cloud before, but basically it's a cumulus cloud like a thunderstorm cloud that's caused by the fire. If you think about the surface of the ground surface being heated so much by the fire itself, it causes the air to rise rapidly, and the smoke column will take on the look of a cumulus cloud. Winds generated from this cumulus cloud, this pyrocumulus cloud, exceeded speeds of 65 miles per hour. And the bending of the smoke plume promoted spot fires. The winds were causing the smoke plume to bend. The crowning fire promoted the rapid spread, and then again these spotting embers. It was described as raining over the areas that hadn't been burned yet, and they started new fires. So all of this contributed to this very rapid spread of the Waldo fire and the burning that occurred within the suburbs just to the west of Colorado Springs. So, in terms of ignition sources, you're probably familiar with fires being caused by lightning strikes, by winds blowing power lines down, spotting from other fires. These are all natural ways, well, natural in terms of the wind blowing. I guess the power lines itself aren't really natural. But these are all ways that the elements can cause fire. And then there's also human-caused fires, which can include things like campfires, and then and then intentionally set fires, which are due to arson. So one of the things that was important in all of these fires, the Oakland Hills fire, the Cedar fire, which is in San Diego, and the Waldo Canyon fire, was this wildland urban interface. So these are neighborhoods that are on the edge of urban areas, so that they line up next to wildland areas, and they are susceptible to fires moving out of those wildland areas. This picture right here is probably the most descriptive that I've seen in terms of the wildland urban interface. This is Scripps Ranch, which is a suburb of San Diego, and you can see the fire. This is the Cedar fire that's moving from the east towards this region, and that you can see that this neighborhood is on the edge of this forested region, and that the fire is moving into the area. This photo was taken by John Gibbons of the San Diego Union Tribune paper. And you can find more information about this from the San Diego State University page as well. They have a really interesting animation of the spread of the fire, and basically at one point these easterly winds, these Santa Ana winds that were occurring, they thought the fire would basically burn until it got to the ocean. It turned out that the winds switched around, and we had more of an onshore flow, which is more moist air, higher relative humidity, that came in and helped stop the spread of that fire.
Liz, this is Henry. Did any of those homes there burn in the?
Yes, yeah, there was quite a bit of damage in this neighborhood.
They did. Okay.
Yeah. Okay, so just to finish up here, I want to talk a little bit about fire weather and the role of the National Weather Service and the Predictive Services Group in supporting decisions being made by the land management agencies, both in fighting fires and also in planning resources during the fire season. This is a screen grab of the National Weather Service homepage, and this is showing red flag warnings, well, this is actually from Monday, which were in effect in Oregon and Washington on that day. So the National Weather Service has a fire weather page, which I have linked right here, and I have a link at the end of this presentation. I want to talk a little bit about the types of services the National Weather Service provides. There are things called red flag events. You've probably heard of a red flag warning or a fire weather watch. And red flag events are considered situations where both the weather and the fuel conditions could lead to dangerous fire behavior. So we take into account both whether there's extreme weather situations, such as very low relative humidity, very strong winds. In the case of thunderstorms that are not producing precipitation, so you could have lightning that also has winds associated with that thunderstorm, but no rainfall associated with it, or very little rainfall associated with it. All those could be critical weather conditions. And then the fuel conditions basically are very dry fuels that would carry fire if they were ignited in some way. A fire weather watch talks about these potential red flag conditions in a 12 to 72 hour situation. It can be issued for less than 12 hours for dry lightning. This would be dry lightning meaning a dry thunderstorm where there's a thunderstorm that's occurring but very little rainfall associated with it. Red flag warnings are warning of an event that's pending or occurring, similar to severe weather warnings that we see. And in this case, the forecaster has a very high degree of confidence that this event's going to occur and that it will occur in the next 24 hours. And this example right here is showing the red flag warning that was in place at that point. So the Weather Service also provides incident meteorologists, or IMETs. These are forecasters who go out on the fire and work with the agencies that are trying to control or suppress the fire, and they give forecasts on site. So this program began actually in 1916. Currently there are 82 certified incident meteorologists, and there have been 66 that have been dispatched this year. Just to put that in perspective, the 10-year average for how many would be deployed at this point in time is 53, and last year it was 76. So you can see that there's a little bit more active season at this point last year. So they began in 1916. People would ride their horses and take their equipment with them that they needed and provide weather forecasts on site on the fire. Things evolved to these campers. This is called, you can see on the side it says Fire Weather Mobile Unit, where the forecasters would go, again, drive out to the fires. They'd stay in the campers and they'd make their forecasts. It's a little bit more high-tech now, as you can probably imagine, as technology has increased. And so, but these forecasters play a very important role in helping the people making decisions in terms of where to put resources, attack a fire situation based on the weather information that they provide. All right, Henry, we're kind of running out of time. Am I okay to keep going, or should I?
Yeah. Why don't we
wrap it up?
go? We'll go to the top of the hour.
Okay. I don't think it'll take me that long, but hopefully.
Okay.
Okay. Another situation that occurs after a fire is the increased potential for flash flooding, and this is it's governed by the fact that the soils, the vegetation, all of these things are modified by the fact that a wildfire has gone through the region. So I want to talk about, a little bit about the time between the fire and the rainfall and how that affects what happens over the basin, what the effects are on water quality, and also just a little bit about the changes to the soil and vegetation. When a wildfire goes through an area and it burns the region severely, the soil is actually modified. It can become what's called water repellent or hydrophobic, and it also changes the characteristics of the soil, making it more likely to erode. And also the vegetation loss can increase this erosion potential. So if it's burned badly enough that surface vegetation is completely removed from the area, in fact the roots that help hold the soil together can be burned as well, then we'll see that there's increased potential for erosion. What we're seeing right here, this is from a page from the USGS, the Geological Service, that shows the effects of erosion. This is actually erosion that's occurred over a burn region. This is the Buffalo Creek area in Colorado, and that and then it's basically showing what the damage has been done by the precipitation that's gone over the fire region. All right, so the Buffalo Creek flood was probably the event in this region which really caused a greater attention to be given to the flash flood potential over burn scars. The fire occurred early in the season in May of 1996, and then before the seasonal heavy rains. In this region, we seasonally have heavy convective rainfall sometime in July. So the problem was that the vegetation had not had enough time to regenerate over the burn scar region, so it was really susceptible to flooding. So any rainfall that fell was no longer, the trees had been damaged enough that the leaves weren't catching the rainfall as it went through, or any of the surface vegetation wasn't catching the rainfall. The soil had been modified so that the rain wasn't soaking into the ground, it was just running off the top. So much of the rainfall that would have been collected, I guess you could say in one way or another, either by the vegetation above the ground or the soil on the top of the ground and below the ground, was not happening. So all of that rainfall was then runoff. And in addition to that, erosion occurred. And you can see this right here. This is Buffalo Creek right here. You can see all the stuff that came down, basically mud and ash and other debris that was carried down into the creek. So this was a pretty severe flash flood with this event. 2 people were killed in the flood. It changed the way flash flood forecasting was done in the region. Now the Weather Service works with the Land Management Agency to determine with them what the threshold values of rainfall are to cause concern, how much rain that they think will be needed before this type of flash flooding would occur. And you can see now that when rainfall events are occurring over the burn scars, especially the relatively new burn scars, that those areas will be alerted to the possibility of flash flooding, even though the storm normally, if there wasn't a burn scar, might not be related to flooding. So there have been mudslides over the High Park fire area, which was the fire that was north of the Waldo Canyon fire near Fort Collins. Again, the Weather Service routinely alerts the public to the chance of floods and mudslides, and again, they're working with the land management agencies. You can see in this picture right here, this is from the Fort Collins, Colorado, and the vehicle driving through this muddy sort of runoff area that's on the road, which of course, as you know, is something you should never do. Turn around, don't drown. That's my shout out for the Weather Service and their flood program. The water quality was also affected, and again, this is from the Poudre River, which was affected by the High Park fire. And you can see this is just some of the sludge and stuff that was taken from the bottom of the river. The effects can last for weeks or months. Basically what's happening is the ash and the burned debris is being washed out of the watershed into the river, and it can actually affect the quality of drinking water if this river is actually used for drinking water in the region. So it was a lost water source. Again, it depends on the frequency of the rainfall and also the amount of rainfall in terms of how long this effect will last. All right, so the current wildfires going on, this is our active wildfire map, which is provided by the U.S. Forest Service. It's an interactive map where you can click on the different fires. You can look at fires in Alaska, Hawaii, Canada. There's nothing going on in Alaska right now, but there are quite a few fires going on in the U.S., mostly in the western, well, I guess basically in the western U.S. The type 1 fires is probably the most severe fire at the moment is near Placer County, California, and it's at 60% contained at this point. Okay, well, I think I'll wrap up here. We have some links to the COMET modules on fire. We have a topics page where you can access all of the different training modules that we have available, including the Advanced Fire Weather Forecasters course. Again, this was developed for the National Weather Service to help train IMETs, and the S290 Intermediate Wildland Fire Behavior course. This was developed for the fire agencies to train their personnel. But there's some very basic information that I think you might find interesting, including our first unit on the fire environment and Unit 11 on extreme wildland fire behavior. And again, Henry will make these links available. If you're not familiar with the COMET program or our MEDIT website, all of our training is available free of charge. We just ask that you register on the site. And here's a few of the resources. I'll expand this a little bit and again send those links to Henry so he can put them on the CoCoRaHS website. And that is it.
Well, thanks, Liz. That was a very very informative presentation. Very poignant since we just went through the Hyde Park fire here. In fact, I remember sitting at my desk and looking out my office window and seeing smoke and actually flames right over the ridge. So it does hit home when we start to see these things. And I'm sure a lot of folks out there have experienced wildfire. Some of you may not have. We're going to take some time right now for the next 20 minutes or so, and if you want to type in some questions, Liz will be glad to answer them on the air. Again, those that she doesn't get to, she'll try to follow up with you via email later in the next couple of weeks. Excuse me, we've had actually a couple questions come in so far. And one from David in Wyoming. He wants to know if you can talk about the transport winds that move smoke several states away from the fire area, and then where we might be able to learn where the smoke is coming from. He was mentioning here in northeast Wyoming that the Montana fire and the Colorado fire were often quite visible and in his area. It almost seemed like they were nearby. So can you talk about that real quick?
Sure. I didn't show any satellite images, but I think that satellite imagery, weather satellite imagery, is really helpful in seeing where the source regions are of that smoke. And I remember here on the Front Range in Boulder as well, we were seeing smoke from the Montana fires, and it's really amazing how far that it can actually travel. So it can obviously travel a couple states. You can again see the plumes on satellite imagery for very large fires, and there's some research going on right now to see if that smoke is actually affecting the development of thunderstorms further downstream. So I think that it's an area of interesting potential for further research.
Okay, thanks. Kevin writes in and wants to know how accurate are predictions of where spot fires will occur. So are there predictions for that, and can we tell where a spot fire might flare up?
Kevin, that's a really good question. There are people who actually forecast the spread of fires that work for the land management agencies. They're called fire behavior analysts, and they have different models that they run. And I'm not familiar with whether they actually have a spot potential model that they run or not, but it's basically what it's based on is how strong the winds are, and they can get an idea of maybe how far spotting might occur. And if you have this well-developed column of convection associated with the fire, as we saw with the Waldo Canyon fire, then you have strong enough updrafts within that complex that you can lift burning embers. So it's just a matter of how far out that they could then travel.
Okay, thanks. Here's one from Jim in Missouri, and Jim wanted to just ask you to comment a little bit more on river sludge. He was making a comment here that sometimes the sludge will choke off spawning beds of indigenous fish, smothering the eggs at the wrong time of year, and so any other negative impacts?
Yeah, I think that it can affect the, right, as you said, the fish population. It can affect the drinking water. When the first, they had it actually on the news here locally, showing the effects of that runoff from the storms right after the High Park fire, and it was almost opaque, that it was just black water running through the region, and that again, it depends on how long it's going to take that river to recover, based on how long it takes for that stuff to settle down to the ground. But then once it's in the basin of the river, it's going to take a while for that to be transported out of the region as well.
Here's another interesting question. This is from Rick, and Rick wants to know, what are the ingredients in fire retardant that's dropped from fires from the air? We saw a lot of that being dropped. Can you tell us what's in that?
You know, I heard actually someone talk about this who was more familiar with the chemical makeup, and I'm trying to remember what the chemical is that it was, and it's losing me, but I can get back to you on that. The person said, though, that if supposedly it's not supposed to affect you. So if you were actually standing underneath the plane as it was dropping the fire retardant, and it dropped on you, you should not be affected by it. But he said, you know, if it bothers you, go ahead and wash your hands, take a shower, get it washed off. So you know, it's not meant to hurt people physically, but it is meant to suppress the fire from spreading.
Sandy writes in and wants to know, when homes are built of fire-resistant materials, metal roofs, stucco, etc., is it possible that the interiors become superheated to cause the building's destruction? So you have the fire retardant stuff on the outside, but could the inside flare from the heat?
Yeah, I think, as you know, depending on how hot the fire is as it's moving through, I think you'll definitely prolong the possible effects of the burning, but you know, anything that's flammable can burn if it reaches its ignition temperature. So if it's heated to that point, then yes, it could still burn.
I think one of the interesting things in the Waldo Canyon fire were that you saw a lot of homes and neighborhoods burned, but there's green grass and green trees and stuff around it. So it must have been, again, intense heat can sometimes set those things off.
Yeah, that's definitely true.
Okay, here's one from Lester, and Lester wants to know, how long does it take a fire to recover if weather conditions are favorable after the fire?
Lester, I'm guessing you mean how long it will take the vegetation to recover from the region, and there are efforts, man-made efforts, to increase that, or decrease the recovery time, but increase the recovery by planting seeds, by you know, doing different things to make it more inhabitable for vegetation. There's been some studies with the Yellowstone fires in terms of how long it took it to recover, and again, it's just based on what your definition of recovery is. But it takes a couple years for really severely burned regions to come back, and along with that flood risk, that flood risk can occur for a couple years after the fire itself has moved through.
Okay, and here's one from Laura in New Hampshire, and she wants to know, how can you determine how a fire starts? For example, campfires or lightning can be small and quick compared to the length and area of a fire. So she's wondering, how do you determine how it starts? I guess they have experts.
They do have experts, and the Waldo Canyon fire is still under investigation in terms of how it started. I think it's very difficult. You can find the ignition source sometimes, depending on how the fire spread, but it's difficult to determine. But yeah, they do have people that actually, that's their job, is to figure out how it started and what the source was of that start.
Richard in Tennessee writes, and his question is that he's seen fire whirlwinds. He says, is that heat rising that causes those whirlwinds? What's the mechanism there?
Yes, it is, and I didn't talk about that, but that's also considered extreme fire behavior, is the development of fire whirls, and they are basically, you know, similar to fire tornadoes. Sometimes they have smoke in them, sometimes they have fire in them, and they can promote the spread. So it's similar to the development of tornadoes. You have winds that are faster above the fire, above the surface of the fire, and that will actually cause rotation to start to occur. And you have these strong updrafts associated with those. Those can be bent, and the fire whirls can occur. So it's a very similar to what you see with dust devils or tornadoes. That same rotation mechanism is in place there. And if you're seeing fire whirls, it's definitely extreme fire behavior and a very dangerous situation.
Paul writes in, this is an interesting question. He says, is most wildlife able to escape the fire, or is there a large loss of life of the wildlife in the area?
There can be large loss of wildlife. Yeah, with animals that are caught in the fire itself. Again, it depends on how fast the fire is spreading.
Yeah, here in Fort Collins, we had a moose swim across Horsetooth Reservoir, which is probably a mile and a half, and wind up in some neighborhoods over here. So, different birds flocking. So it definitely, you definitely see the wildlife trying to get out.
Right.
Doug from New Hampshire wants to know: are there any interesting similarities between wildfires and urban fires?
That's a really good question. I'm trying to think of what they might be. I mean, obviously wildfires can move into urban areas. I think that the way that those fires are approached can be very different, obviously. So I guess I can't come up with any off the top of my head.
Okay. Edith from Texas wants to know, should homeowners in Texas who live near wildlands remove cedar trees near their houses to prevent spread of fires from wildfires? And I guess this could go anywhere with vegetation or trees close to your house.
Right. There is an active effort to help people protect their homes from the spread of wildfire, and it's called FireWise, and you can find that on the web. I will send that link to Henry as well. That gives you some great ideas of how you can protect your homes. And again, they talk about having a defensible space, so a cleared area around your home which could act as a fire break. And it's amazing how effective those can be depending on the severity of the fire.
Paul has an interesting question. How large does a fire have to be before it is named? We see Waldo Canyon, High Park, and so forth. And when do they give a name to a fire?
That is a really good question. I do not know the answer to that, and there's also, how do they determine the name? That's also a good question. There is some references on the website about that. My guess is that it's when it's really causing an issue, when it's big enough that it's they're assigning firefighting teams to it, and you can see that there's different fires that are very different sizes. That the Flagstaff fire, which was west of Boulder, was a relatively small fire, but it had a name because it was threatening the community.
Yeah, I wonder if part of it's the point of ignition or where they determine that. Okay, here's one from Rick, and Rick wants to know, can you address the levels of fire response and how local, state, and federal resources are allocated at each level?
Oh, that's a really good question, and I don't have the details on that, but I can tell you that depending on the severity of the fire and the people who are working the fire, they will order different levels of teams. So, for instance, there's a Type 1 team, which would be the team that's associated with the biggest threat of a fire, and basically that's the one that's being taken most seriously. And then there's different levels that go down from there. The really interesting thing, I think, about incident support or incident command with the land management agencies is that they span federal and state and local agencies. They do it very well. They're very well organized, and they are able to take people from a variety of agencies and fight the fire, direct them as resources and do it very well.
David writes in back about naming the fires. He says that under Incident Command Support Protocol, all wildland fires other than a couple of acres are typically named, and generally the name is one that describes a location or some other distinctive feature. So thanks, David, for letting us know on that.
Thank you, David.
Sandy wants to know, how flammable are pine cones and pine needles, like big ponderosa needles, as they age on the ground? So that's a good question.
They are very flammable. You have the just the chemical content associated with them, just the fact that they're very dry, brittle fuels. And actually, maybe you've used pine cones and pine needles to help start a campfire, help start a fire in your fireplace. Those are very flammable. And again, we talked about the time lag associated with fuels. Pine needles are considered 1-hour fuels, so they will react very quickly to changes in humidity. And just as an aside, for those of us in the West would think of pine needles being highly flammable. In the Southeast, pine needles are actually used as mulch in gardens. And in fact, when I was living in North Carolina, we had pine needles, and the first thing I thought was putting pine needles up against the house. This is not something we would do in Colorado.
Stephen in Texas is talking here quickly about the debate about conducting prescribed burns or reduced fuel loads while burn bans are in effect throughout the county. What are your thoughts on this?
I didn't know that was possible. I'm not familiar with that at all. I think that prescribed fire is very controversial because of issues like the Cerro Grande fire where it's gotten out of control. But it's thought of as being a very effective way to manage the fuels in the area and to help prevent even more severe wildfires from occurring.
Okay, well, I think we've covered most of the questions. One last one here coming about how deep will the soil be affected by large fires? That's an interesting one.
That's a good question. It usually goes down a couple of inches, so it can have a significant effect on the soil itself along the surface. And again, it's inhibiting the water soaking into the soil, and it's also making that soil more susceptible to erosion.
Well, we're gonna cut it off here for today, and we thank you, Liz, again for being part of our series. A very interesting one today on fire weather and winds and wildfire. We will post all this information in the next couple of days on our website. If you go to the CoCoRaHS website and click on Weather Talk webinars, you'll see that. You actually will have the actual webinar up again. So if you have friends that would like to watch and listen to this, we'll have that available too. And actually, all of our past webinars are available on the CoCoRaHS webpage, so you can go back there and watch any of them at your leisure. A couple of things before you guys leave today as you log off. Again, if you would take the survey at the end of today's webinar, those of you who are on it live can do that. And we want to talk about our next webinar coming up on Thursday, August 23rd. That's a little over a month away. Bill Capel from Applied Weather Associates in Monument, Colorado will talk about extreme rainfall, how we analyze it, and how the weather data is used. And that should be an exciting one as well. So we look forward to that. Again, Liz, thank you so much for being with us today, and we'll talk to you guys later. Have a good day.
Thanks.
Bye-bye.